download it if you wanted to. What you have is, it should look like this where it says raw data. These are monthly returns to, I've just given it a pseudonym. Again, this was the MBA investment fund. So this was the full-time MBA students managing. But this is the first 41 months of their performance.
In
So
95.
Sorry?
In 95.
Starting in 95.
Can you kind of make that bigger?
Yeah, let me try.
Thank you.
Is that better?
Yeah, much better, thank you.
Okay. And then we won't mess around with the Fama French factors, so let's just compare relative to the S&P 500 and see what we get. And then there are annual T-bills, which we chop down by just dividing by 12. And so here's what I want you to do. Where I'm going to calculate excess returns, because this is the thing to get right. Everyone's listening.
What's the file called, Professor?
It's, thank you, sorry.
I was just answering her. Case 4.4 data mutual fund performance.
Go to the module for, yeah, thanks. To be based on calculating excess return. Okay, so the trick with all of this is every bit of what we're going to do is going to be based on calculating excess returns for the two things we're comparing, which is the actively managed fund, listed here as AFNDX, and the S&P 500. Okay? So if everyone's following, pull that out a little bit. So I'm going to take, for month 1, the return to the actively managed fund was 9.25. 5%, that's not annualized, that was a really good. It started strong, oops. And then I'm gonna subtract off the monthly TIVA.
Okay,
You.
sorry. You did say you're gonna take care of it, so. Anyway. I'm gonna start the show.
Which one?
The, like,
Okay.
Downton
I'm,
Abbey.
I'm not far. I'm just getting organized. I'm downloading
So
stuff.
it's like, I'm trying to think, care if I start the show?
Nope.
I'm white on my feet, so it's not easy to talk, I'm sorry.
What?
And I teach for
Okay.
not easy to talk.
Alright, well, yeah.
What do you think? What time is the park coming back?
310.
Started strong, oops. And then I'm gonna subtract off the monthly TIVA. So of that 9.25% that the MBA students earned the first month of existence, with 42 basis points of that, they should have gotten just for investing their money in the market, in the risk-free rate. So their risk premium for that month was the 8.834. Yeah, right.
Just the risk-free rate that's email, what duration, is it a 10-year that you're commonly using?
That's a great question, we haven't really talked about it before. Yeah, right.
Just the risk-free rate that's email, what duration, is it a 10-year that you're commonly using?
That's a great question, we haven't really talked about it. That's what from 4 or 5 years. So then I'm gonna do the same thing for the S&P 500. So this is important, everything else kind of follows in a pretty straightforward manner once you get this excess return data set up. So I have excess returns, you can just fill, just to have in red, just for highlighting purposes, or monthly excess returns to the active manager as well as to the benchmark. Every bit of what we're going to do now is going to use that data. So that's the key of getting all this started, get that set up right, everything then flows through pretty smoothly. Yeah? Everyone okay? All right. Now I've already pre-populated some spreadsheets here, let me go through them. So this was the full-time MBA and sorry?
In 95.
Starting in 95. What we get? Here, with headers there. Where I'm gonna calculate X by 12. This is the thing,
I was just answering her case 4.4 data mutual fund performance.
go to the module for class 4 and in case problems. there's an Excel. This is important, everything else kind of track that data. So let's start with the chart. So now that I have my excess returns, remember the Sharpe ratio is the average excess return divided by the standard deviation of excess returns. Yep. We all did that already. That was one of the questions on the last assignment. So all I've done is just strip out the Fama French returns and stuff and just sort of, you know, move over to, so now, now that I have my next, this started, get that. Over to, so now, the Sharpe ratio, and then the Sharpe ratio is just going to be the ratio of those two things. So the computation of this is not a huge stretch for us. Again, you've done all this, you've done it well in other contexts. So now tell me what my conclusion is about how the managers performed relative to, again, think about, you know, if I hired these students to manage funds for me, my alternative is I could have been invested in an index fund matching the S&P 500. So how happy am I with that?
Bless you.
All right.
Sure. The politician.
Let's interpret that. How should we interpret a number for the Sharpe ratio at 0.284?
0.28 units of return
First of all, sorry, go ahead.
per, so 0.28 units of return per unit of risk.
Units of excess return per unit of risk. Perfect. Which, that's a perfect explanation. Is statistic. Student managers, I'm not, but that's all it is. Yeah, we can calculate trainer in terms of the development in this area. In order to get the beta we need for the trader measure, we have to run the Jensen alpha regression. All right, let me show you how. We could do that. You can run regression. So again, here's my excess return data. And so the excess returns on the manager I'm evaluating is my dependent variable, my Y variable. And my X variable is the excess return on the benchmark.
Can you expand that?
Yeah, I'm sorry.
My eyes are terrible.
Yeah, sorry about that. All right, now you can do regressions any way you want. I usually just do it within Excel. So if you already have you done this in other classes?
Yeah.
So you already have, if you go to data and data analysis, you should have the regression package already in there. Yeah. So we just have to specify, I don't think I can blow this chart up, but we specify the range for the Y variable, which is the excess returns on the fund we're evaluating, the MBA investment fund. And then the excess returns on the X variable is the excess returns to the S&P 500. And then we run the regression. All right, so the coefficient, the estimated coefficient on the, okay, is that better to see?
Yes.
The coefficient on the X variable, the 0.91768, that's beta. And the intercept is Jensen's alpha, which is 0.22. So we can use that beta to go back and just take the same average excess return that we did for Sharp and divide it by the 0.918. And for the S&P 500, we take the average excess return and divide by what?
1.
Good. Just take the same average excess return that we did for Sharp and divide it by the 0.918. And for the S&P 500, .918. And for the S&P 500, we take Sharp and divide it by the .9 by what?
1.
Good, got it. The beta of something with itself is 1 by definition. So now tell me what we would conclude from Trina. students do better or worse? Better in this case. Oh, now that's interesting. Why did Sharp tell us they did a little worse, and Trainer tells us they do a little better? How is Sharp measuring risk? Total risk. Trainer is looking at just the systematic portion of risk. If you look at the R squared, in this regression, we can interpret R squared as the percentage of total risk that is systematically related to the market. So kind of roughly put, this is a fairly poorly diversified portfolio. So the total risk in the portfolio the students manage, only 60% is systematic and the other 40% is still diversifiable. Now, that's a conversation we had back in the day. All right? So think about what Sharp is doing is holding the managers accountable for all the risk they take. So they look worse. Trainer says, no, let's throw away that 40% that could be diversified and look at just how they did relative to their systematic risk. So when you throw away that much unsystematic risk, they're going to look better, which is what happens. So which is the better measure to use? Here's where it gets interesting to me. Yeah.
I think Sharp.
Let me, again, use the answer I heard earlier. It depends. Yeah. Josh is investing with the MBA fund managers, and he's all in. That's the only thing is in his portfolio, is an investment with the MBA investment fund. Which measure should he use? Sharp, clearly, because whatever risk they create, he lives with. Cray, on the other hand, is invested with the MBA fund, but he has 25 other investments, spread around, all different asset classes. So now for him, Trainer might be more relevant, because when he puts the MBA fund in his diversified portfolio of holdings, it's the systematic risk that's going to be left. Yeah? So which should I produce if I'm producing a report with all of this? I got to produce both, because I don't know whether Josh or Cray is going to be reading this. Yeah? So again, there's no one single number that's going to be the be-all and end-all. But let's get to a good point to wrap up here. So we already ran Jensen's alpha. That's the 22 basis points. Now, unlike Sharp and Trainer where we don't really know how to interpret it, another advantage of Jensen's alpha is that we can actually interpret the number. That 0.22 means that the NBA fund systematically earned 22 basis points per month more than they should have. So you can multiply that by 12 and you get a nice annualized alpha. So we have a nice interpretation. So it's still, but we can't be very certain that either better performance over the same time.
So is this
What that would do is cause me to change exactly what these
Actual return minus universe.
I could go back to minus the return to the benchmark. But here's something that's a little bit clever. If you see this column that says difference, that's just numerically the difference between the excess return on the manager and the excess return on the benchmark. Because I could go back to the original data, but both of these things net out the same risk-free rate. So if I net the two, one from the other, the risk-free rate is canceling out. Everyone see what I'm saying? Yeah. So you can just take the difference in these columns, and then the information ratio is going to be the average and standard deviation of those excess returns. in this case, on a monthly basis, would be 0.026. And the way you would annualize of those excess returns. Which in this, the average and standard deviation of those excess returns. Which in this, of those excess returns. Which in this case, on a monthly basis, would be 0.026. And the way you would annualize a monthly information ratio is to multiply it by the square root of 12, 12 being the number of months in a year. And so we would tend to see that reported as an information ratio of 0.09. What can we say about that? Are we happy with it?
Positive.
Yeah, that's the first thing to think of. It's positive, which means that on average, they're outperforming the benchmark each month. Again, the only way Sharpe or the information ratio is going to be positive is if the numerator is positive. Is that high enough to satisfy us?
Oh my God.
Yeah, again, no theory here. In practice, what most people argue is to be considered a good manager, you need to generate an annual information ratio of about 0.5. Positive, which means is you need to jump far short of kind of what the industry standard is. But again, there's no theory there. Let me show you one more thing and then we're out for a break. Sharp. Measures a manager's performance relative to T-bills. The information ratio measures the manager's performance relative to a benchmark. Information ratios, I didn't really hear people talking much about these until the 90s. We designate the managers